Good morning. I'm Chris Lund, R&D Scientist and Product Manager for the Irrigation Management Group at Decagon Devices. Welcome to Decagon's monthly virtual seminar series. Thank you all for joining us. Our speaker today, Dr. Lars Pierce, will be talking about the Vineyard Soil Irrigation Model, VCM, which he's developed in partnership with the California Department of Water Resources, NASA Ames Research Center, and Constellation Brands. VCM combines Landsat satellite imagery with weather and soils data to estimate soil moisture and vine growth in wine grapes, providing growers with an improved understanding of daily vine water needs over the growing season. Dr. Pierce completed his PhD at the University of Montana with Steve Running before joining the faculty at California State University, Monterey Bay. Before we start, I want to let the audience know that Dr. Pierce will be taking questions at the end of his presentation. I'll help curate that. And with that, I'll turn things over to Lars.
All right, thanks, Chris, and thanks to all of you out there who've logged in today. I'm just going to give you kind of an overview of some of the irrigation modeling we've worked on and show you how it's set up, that sort of thing. Let me introduce a couple of my colleagues. Andy Michaelis at NASA Ames Research Center has helped a lot with the software development, and Daniel Bosch from Constellation Brands has helped with report design and giving us access to vineyards and growers and up and down California. So for the presentation this morning, I'm going to go through a bit of history in terms of the ecosystem water balance modeling, the motivation for the current modeling effort. We'll talk a little bit about the VCM water balance model. We'll go through some of the input data sets, including the satellite imagery, which is important in tracking canopy development. I'll talk about how we build up these databases, and then the challenge in terms of scaling to more vineyards is automation. Talk about what we're working on there. Look at some of the forecast reports themselves, talk about what's in there. We did an irrigation trial last year. We'll talk about that and some of the results, and then briefly talk about how to set it up for a vineyard if anybody out there is interested in that. So just a bit of history with Decagon. I did my PhD over the hill at University of Montana, and we took a Sunflex septometer prototype Acupar back in 1988, and we tested it out in some conifer forest stands measuring leaf area index. And Galen was nice enough to review the paper and provide us with the instrument and give us some feedback, and it turned out to be a pretty useful piece of equipment. So several years later, he's back in 1988. A lot of this ecosystem modeling and a lot of the water balance modeling we're using today started back in 1988 with the Forest BGC model at the University of Montana in Steve Running's lab. And a lot of what we do today was developed back then, including the data integration. So you see that flow chart at the bottom of the slide. You'll recognize that later on when I talk about the current work that we're doing. The current version of all the data integration is something called the Terrestrial Observation and Prediction System that's been developed by the folks at NASA Ames Research Center out in Mountain View, California. And it acts as a platform for hosting ecosystem simulation models. You can, the TOPS will read in data, satellite data, ground-based weather data, whatever you need. And so you can actually nest your ecosystem model with inside TOPS, and TOPS acts as the go-between your data sets and output. And so we'll talk a little bit more about that. Let's talk a little bit about irrigation. In terms of the growers that I've worked with, there's usually some target water stress or soil moisture that the grower wants to try to achieve by certain dates in wine grapes. You might start out the beginning of the year. This time of year, the vines are starting to flower. And so you want to minimize fruit set or minimize water stress during flowering and fruit set, because that's when water stress can cause the flowers to abort berries. You lose yield, that sort of thing. After the fruit has set, though, you can ramp up water stress or decrease soil moisture. And you can actually use stress or lower soil moisture to stop vine growth at wherever you want it. So in wine grapes, if you don't get the canopy large enough, you can't carry the crop that you want to ripen by the end of the year, so you lose yield. You have to actually drop clusters. And if you get the canopy too large, it shades the berries, and that affects the wine quality. It gives you green pepper flavors in the wine, and then also it affects your crop the following year if the buds don't get sunlight. And then finally, towards the latter half of the season, growers who want to maximize quality will continue to increase the stress, while growers who want to maximize yield will back off a little bit on the water stress at harvest. So that's sort of the irrigation goals, and obviously the goals are different for different growers, but that's sort of the goals in a nutshell. The challenge is then, how do you maintain these goals across a variety of management blocks, which would include different wine grape varieties, different soil types, spacings, row vine spacings, and then across different years, wet springs, dry years, that sort of thing. So we developed a simple water balance model, and I'm just going to go through real briefly here what a water balance model looks like. You can see here we have our vines, and we have our soil moisture, our soil reservoir here. The blue is the soil moisture. We have our sun there. Simple water balance model, all we do is keep track on a daily basis, starting at the beginning of the year, of the deposits of water into the soil reservoir, so rainwater or irrigation water. And those data can either come in from CIMIS, which is the California Irrigation Management Information System. That's the weather station network in California that we use in agriculture, or it can come in from National Weather Service forecasts for the upcoming week. So we bring in both for the irrigation forecasts and provide a look out to the upcoming week in terms of vine water stress, soil moisture, and that sort of thing. We also need some type of data on irrigation, obviously, so that can come in from grower irrigation logs, or we can measure it with flow meter. We also need to keep track of withdrawals of water from the soil moisture reservoir, so that's through obviously evapotranspiration and deep drainage. And so for evapotranspiration, we use the standard crop coefficient Canopy ET model, where we have the crop coefficient, the K sub C, and that's multiplied by an ETO. And so that gives us a first order estimate of how much water the canopy might be using. And then we also keep track of drainage, which is just if soil moisture exceeds field capacity, then we run some drainage down below the root zone. So then the size of the soil reservoir determines how much water you can hold, or the field capacity, and that's a function of the clay content, the sand content, the gravel content, and the rooting depth. So clay and sand control the release of soil moisture and the relationship between soil moisture and plant stress. The gravel just displaces soil volume, and so it allows for better drainage, but it also reduces the capacity of your soil to hold water. And then rooting depth determines how deep the vines can reach for water. And so shallow rooting depth means the vines won't have as much access to water as deeper soils or deeper rooting depths. And then on a daily basis, to keep track of soil moisture, then all we have to do is compare the deposits with the withdrawals, and we get a daily estimate of soil moisture. And this is another way to look at the ET model, or the VCM model itself. We have the Canopy ET model, which is the upper equation. So ETC is equal to the crop coefficient, the K sub C, times the ETO. We get the crop coefficient from satellite imagery. I'll talk a little bit more about how we do that, so we can track that over the growing season. Then if we know ETC, we can make an estimate of soil moisture. Again, it's soil moisture today is equal to soil moisture yesterday, plus irrigation and rainfall, subtracting off ETC and deep drainage. And then if we know soil moisture, we can make an estimate of leaf water potential. And if we can make an estimate of leaf water potential, we can calculate this KS factor here, which is a stress scalar. And so as the vine becomes more stressed through the growing season, then we reduce our our total canopy water use. And so we need to account for that in vineyards because we want to stress the crop at certain milestones during the season. Other crops you don't necessarily need to worry about if you're not running those crops under water stress or if they don't benefit from water stress. So you can see that the inputs we use are the NDVI from satellite imagery. We get air temperature, rainfall, and ETO from the weather networks. We can get the forecast weather data from the National Weather Service. We bring in slope and aspect for the vineyard and the vineyard blocks, soils data, irrigation, and block data, and we can calculate different outputs based on the water balance, ET, canopy growth, soil moisture, leaf water potential, drainage, and irrigation. And we do all of this on a block-by-block basis within the vineyard. I'll talk more about that. Obviously, verification of the model estimates are important, both in making sure that the model's working and in helping us to calibrate some of the parameters, particularly rooting depth within the model. And so we can use soil moisture to compare to the measured soil moisture to compare to model estimates of soil moisture. And we can also use pressure bond measurements or leaf water potential to compare model estimates of leaf water potential to measurements. And those give us confidence that the model's working or not working. And if it's not, then we need to look in is there something in the way we model that system that's not working, or are some of the inputs not working properly? So we learn a lot by doing those comparisons. One of the other things we like to take advantage of are the web-based geospatial data sets. So over the last 5 to 10 years, there's a lot of geospatial data has become available over the internet. It's getting fairly easy to access, and so some of these data sets have an important bearing on irrigation and plant water needs. The first one, obviously, is weather, and so we can get weather in California from the California Irrigation Management Information System. You see the blue dots on the map there. Those are just a smattering of some of the stations located up and down the state. The red blotches there are some of the vineyards that we're currently working in, and so you can see that there's some gaps in the data, and so occasionally we do have to install supplemental weather stations to fill in those gaps or extrapolate from a weather station in the valley bottom up to a vineyard on the side of the hill. So we use a few Decagon weather stations. We move those around, develop calibrations for them from local CIMIS weather stations. Another geospatial data set that's out there and available is Topography, or the digital elevation models from the U.S. Geological Survey, and those can give us slope and aspect. And slope and aspect affect ETO. And so if you're on a south-facing aspect, you can expect to have more incoming solar radiation and therefore greater evaporative demand compared to a north-facing aspect. And so within the model, we account for that using a cosine correction. We also rely heavily on satellite NDVI data, and I'll talk a little bit more about what the NDVI is. It's the normalized difference vegetation index, and I've got a slide showing how that's calculated, but that helps us track vine growth and cover crop growth over the season, and we can get that from the U.S. Geological Survey as well. It's free. And then we have soils data, county level soil surveys from the NRCS, and that can give us the sand, clay, and gravel content information. So in terms of the satellite imagery, we pull Landsat imagery from the U.S. Geological Survey, and that's a partnership with NASA. NASA builds the Landsat satellites. USGS manages the imagery once the satellites are in orbit. The Landsat series of satellites, now we're up to Landsat 8. They started in 1984, and the USGS began providing free imagery in 2009. So you can go to the USGS Glovis website, and you can select an image and download it and process it to NDVI, which I'll show you how to do. fairly coarse resolution. The pixel size is 100 feet by 100 feet. So a 10-acre vineyard block might have about 40 pixels. But it's fairly frequent temporal resolution. So every 16 days, the Landsat satellite passes over the same spot on the Earth and can take an image. There's actually 2 Landsat satellites in orbit currently, Landsat 7, Landsat 8. So they're staggered by 8 days. So for any spot on the surface of the Earth, we can get coverage every 8 days. And you can see in the graphic on the upper right there, that yellow box is a scene, and it's about 100 miles by 100 miles. And the Landsat satellite records bands in several wavelengths. What we're interested in is the red wavelength and the infrared wavelength, because we can use that to make the NDVI. So here's a little bit more information about the NDVI, the Normalized Difference Vegetation Index. This is a typical reflectance profile for a plant, and you can see that the plant absorbs highly in the red for photosynthesis, but it reflects a lot of near-infrared light. And so if we take a ratio of the red to the infrared, then that should be related to the amount of green vegetation that the satellite is seeing. And so that's what the NDVI is. It's just the near-infrared minus the red divided by the near-infrared plus the red wavelengths. And so with the Landsat 7 satellite, the red band is band 3, and the near-infrared is band 4. And with the Landsat 8, the red band is band 4, and the near-infrared is band 5. In terms of looking at the vineyard canopy and monitoring the canopy dynamics with the NDVI, it gives us a great tool at looking at what's going on over the growing season. So in the early season, we can monitor the cover crop, because the cover crop is using soil moisture before the vine leaves out. And so we need to calculate what the cover crop is doing and how much water the cover crop is using from the start of the year. And then once the cover crop is cultivated or plowed under, and we also might get some shoots thinning, we actually see a decline in the NDVI in most vineyards. And then as the vine starts to leaf out and grow, we see that the NDVI bumps up and then levels off. And so this gives us an annual signature for a particular block, and there's some indication that variations within the NDVI within a particular block increase prior to disease. And so the NDVI provides a really useful tool for monitoring vineyards and agricultural crops. This is just a set of images to show how the NDVI changes over the course of the growing season. This is for a Napa Valley vineyard. The vineyard on the left there is about 500 acres, just to give you a sense in scale. And this is in June, late June, early July, late July, early August, late August, and September. So you can see that the canopy greens up, is greening up in June and July. It hits its peak, and then it starts to level off or even decline depending upon the amount of water stress. The brown blocks here are actually replant blocks, and so the vines were pulled out mid-season, and they're going to be replanted with new vines the next year. And the blue areas here, those are the high NDVIs. Those are the densest canopies, the most radiation absorption, and then the yellow and the green are intermediate. So you can see how those change over time. Here's another way to look at some of the data. This is a vineyard in Monterey County, showing the mean NDVI by vineyard block from 2011 through 2013 for 3 different years. So this left side plot is 40 different vineyard blocks in that vineyard for 2011, 2012, and 2013. 2011 was fairly wet down in California. Last time we saw any rainfall significantly, I shouldn't say that, actually. We got pretty good rainfall last year in December, but you can see the canopies got larger in 2011 because we had more rainfall. And then 2012 and 2013 were more similar. And you can see then from the NDVI, then we get we can have a vineyard signature that, you know, might even be related to vintage and wine quality. And we can look at the range of NDVIs within a particular vineyard within a particular year. And this gives you sort of a sense of the spatial variation that the vineyard manager has to deal with in any particular vineyard in any one year, and then between years as well. Another thing we can do with the NDVI image that we found vineyard managers like to see is we can compare the current year NDVI, so in this case, you know, August 2014, with an NDVI image from the same time during the previous year. And we can subtract one of the other, and we can get this NDVI difference image. And so when you look at the difference and you scale it relative to the prior year, then what you see in the middle image is the brown areas are areas where the canopy or the NDVI was less in 2014 than it was in 2013. The blue areas are where the NDVI this year was greater than 2013, and then the white areas are neutral areas, not much change between years. And so you have to remember that the NDVI is sensitive to both the vine and the cover crop, and so removal of the cover crop can affect this. But out in August, the cover crop's already gone, so what we're seeing here is primarily differences in vine growth from year to year. And so the grower can use this to see, am I getting to my target canopy? And if I'm not, which blocks, where is it delayed? Where am I ahead? Helps the grower focus in on what that target canopy is going to be. So let me talk a little bit about how we set up the databases now for feeding into the VCM model on a vineyard basis. And so we use a farm shapefile, and that acts as a cookie cutter to extract the means of all the input data sets by block. And so a shapefile is just a farm boundary file. It just shows the boundaries of the individual blocks within a particular vineyard. And not all growers have this, but they're fairly easy to put together. And so for some of our new growers we're bringing in this year, we sit down with them and help them put together a shapefile, or a KML file is similar to a shapefile if you're familiar with Google Earth. We use that as a sort of a cookie cutter, and we can stamp out the mean NDVI by date for each block. We can stamp out the soil characteristics and get the means by each block, and we can get slope and aspect means by block. And we can use those to create the basic input data files. So we have a block, we have different dates, and we have NDVIs on those dates, and those are average NDVIs for the block. Same with the sand, gravel, clay content, slope, and aspect. Some additional information that we need to bring in the grower irrigation data. So particularly, how much water did the grower add up through the last week? We need to know that, because that's an important input to soil moisture. And then we also want the grower to tell us, what are your irrigation goals? So what targets and dates do you have in terms of water stress? And then we can use that to then estimate within the VCM model how much water would be needed to hit those dates and water stress targets over the course of the growing season. So that's kind of a summary of compiling all the VCM inputs and summarizing the outputs, but it's a fairly onerous task. And so in order to do this across multiple vineyards, then we have to focus on automation. And so part of that is bringing in the TOPS, the Terrestrial Observation Prediction System, which handles all the input and outputs for the VCM model. And that TOPS then with the software allows us to automatically create the farm database, run the VCM model, bring in the grower irrigation data, and then summarize the outputs and mail those, summarize those outputs into a PDF file. That's a little easier to interpret than an ASCII file, and send that off to the grower. So TOPS handles all of that. VCM handles the water budget calculations. Just to give you an idea of what needs to be automated and what we're automating and what is automated, we're still working on processing of the Landsat NDVI data, so bringing that data down from the USGS website, correcting it for the atmosphere, and then calculating the NDVI from that. And once we do get the databases set up, we need to continue to work on the software for extracting all the input data sets using the Vineyard shapefile. We're still doing a lot of that by hand, and so that sort of limits us in terms of the number of vineyards that we can take on. The TOPS data, or the TOPS interface, currently brings in the CIMAS weather data for a particular vineyard and pulls that data in, also pulls down the National Weather Service data, so we don't have to worry about that. It also can receive and format grower irrigation logs, and so there's probably the format for grower irrigation logs is probably as numerous as the number of growers, so everybody seems to have a slightly different format, and so that's a little bit of a challenge because you don't want to force a grower to use a particular format in an irrigation log because they could, you know, it might be, if it's too much work, then they'll just skip it and they won't worry about it. We've got a lot of other things to do besides reformat data. So we're still working on that, trying to find a few common formats that might work across the vineyard industry. We cross-reference all the input data by block name, and so we have to make sure the block name in the shape file is the same as the block name in the irrigation file, so that we can load the right irrigation data with the right block. The data feed into VCM is pretty good. Running VCM is now being handled by TOPS, and TOPS does a nice job of summarizing the output and emailing that to the grower in an automated fashion. One of the challenges is the quality control, and so that's something that is going to be difficult, if not impossible, to automate. And so how do we handle that going forward? This is just another kind of a summary in terms of how the current reporting is done on an automated basis. So we have our grower there over on the left, harvesting their grapes. The TOPS is constantly pulling the grower email. And when the grower sends the updated irrigation logs to the TOPS server, that starts a whole series of events. First, TOPS goes out, it loads in the latest weather data up through yesterday. It loads in the National Weather Service 7-day forecast data up through the upcoming week, and it is now currently processing and loading the Landsat imagery. We still have to automate some of that. So it gets those data sets updated and set up for that particular vineyard. We bring in the vineyard database that we've already created, and TOPS feeds in that data to the VCM model. It runs the VCM model. One of the things we're working on now is bringing in wireless data sets, so data that gets uploaded to the web. We can access that and bring that in, and we're starting to do some of that with irrigation, and we could do that with soil moisture as well. Bring that in for either an input on the irrigation side or soil moisture on the validation side. And then TOPS takes the output from the VCM model and generates this PDF report, and it automatically sends that back to the grower. So every time the grower emails the TOPS server, this whole process runs, and the grower within a couple hours gets an updated forecast. This is just a quick summary of what the forecast looks like, what we currently send to the grower, sort of version 1. The first table is a forecast summary table, so this was generated on August 26th of last year. And so what was the forecast for the upcoming week? Some basic metrics in terms of temperature and growing degree days, ETO and rainfall. Then we compare the current year to the prior year. So we look at the growing degree day sum in 2014, and we compared that to 2013. And you can compare in that graph, the red and the blue lines. And you can see that 2014 was quite a bit more advanced than 2013 in terms of growing degree days. And in 2015 is similar to 2014 down in California this year, which is good for flowering and getting the grapes all the way through the growing season. You know, of course, it's bad in terms of water availability, which is I'm sure you've all heard about. We also provide a graph that looks at the current ETO relative this year relative to last year, and rainfall starting from January 1st relative this year relative to last year. We bring in the current Landsat NDVI data, and then we also bring in the current difference image from the prior year. In the next section of the report, we summarize the irrigation coming into the model, what the leaf water potential is, the soil water deficit, and the canopy, where the canopy is relative to the peak. And so these first 5 columns on the left then are up through yesterday, so up through the date of measured weather data, and the 5 columns on the right are for the upcoming week. And so the first thing the grower looks at is, did we get all the irrigation data in there? So do we have the total, and do we get the last date of irrigation? Because if we don't get those correct, then the rest of the model calculations are going to be off. So from soil moisture, we estimate a leaf water potential. And if we know the threshold leaf water potential, or the target that the grower wants to be at, then we can just subtract one from the other, and we can get an estimate of the soil water deficit. So this is for the end of the upcoming week, this table here. We can look at our threshold. We can look at what the current estimate of leaf water potential is for that particular block, and we can calculate a deficit in terms of gallons per vine that the grower would need to add to go from 12 bars water stress back down to 11 bars. And this is the canopy. So where is the canopy relative to the peak? And since we're already in August, we've already reached and surpassed our peak. The final section of the report just provides a little bit more visual for each block. There's a paired graphs for each block. The left-hand graphs show canopy growth, the solid blue line for this year, and the dashed blue line is canopy growth for last year. So you can see, you know, that, of course, if you're using a growing degree day model, as well as it's showing up in the NDVI, that last year we were sort of 3 to 4 weeks ahead of where we were in 2013. The orange line is the estimate of what the cover crop is doing in the current year relative to last year. And I think, as you can imagine, this time of year is a little tricky in terms of figuring out what the vine is doing versus the cover crop, because for many vineyards, they're both out on the ground at the same time. So we have to use a growing degree day model to estimate what the vine canopy growth is for the current week, and then we compare that to the NDVI, and any difference then we can apportion to the cover crop. And then the right-hand graph just shows some basic water balance metrics for that block. Soil moisture in the green, the solid line is this year, the dashed line is last year, and estimated leaf water potential from soil moisture. We estimate leaf water potential from soil moisture, and the solid red line is this year, the dashed line last year, and we also make an estimate of deep drainage. And so you can see we didn't have any deep drainage through the irrigation period for either year, so that's good. We also do a summary report for the grower, and so we compare the water balance under the grower irrigation to the grower defined goals. And so again, 2 tables and a set of paired graphs. We can do some basic summary metrics. What was the change in soil moisture over the season from April through October? How much deep drainage did we get? What was the total ET? What was the total irrigation? And what was the ratio of irrigation to ETC? And so how much water did they, in terms of ETC, how much ETC did they replace through irrigation over the course of the season? This is under the grower irrigation logs. And then these are the grower-defined goals. So VCM uses those grower-defined water stress targets to then estimate irrigation over the season. And the grower can compare what they did to what their goals were and see how well did I do. And in this case, it seems like the grower did great, you know. Irrigation, for the most part, they use less water. And I say great, it could be good, it could be bad. Maybe the grower stressed the vine too much, and that would affect yield to some degree. And so it provides the grower anyways with a metric to see how well did I do compared to what my targets were. And this is the same, but just means of leaf water potential, estimated leaf water potential over the growing season. When did I hit 10 bars leaf water potential? Because that is usually a sign of when your canopy is going to stop growth above 10 bars. And so you don't want to hit that too early, and you don't want to hit it too late. And then what was the maximum that I hit? And so again, under grower irrigation versus the grower irrigation goals. And this just provides a cumulative look at the ET and the irrigation, as well as deep drainage and estimates of leaf water potential. And here we've also plotted leaf water potential observations that the grower took at that time of year so that we can gain some confidence that the model might be working for this particular block. These little spikes here are associated with rainfall rather than irrigation, so some deep drainage there. In terms of the software development, then, we're currently building out and testing the software. Last year, we delivered these forecasts to 13 vineyards in Central California. This year, we're expanding to 35 vineyards, and that's pushing our abilities as much as we can right now in terms of getting new vineyards set up. And so it's helping us focus on where we need to automate the software next to increase the number of vineyards we can bring on. In terms of running for these particular vineyards, we're using, again, the Landsat NDVI, the USDA county level soils, slope aspect. We're using the CEMIS weather data and National Weather Service forecasts. And then we're also bringing in the grower irrigation logs. So they email their irrigation logs. And last year, the logs were usually updated by Sunday evening, and then the growers emailed us the logs on Monday mornings. But that's not a rigid schedule. It can be flexible depending upon what works best for each individual grower. You know, as you can imagine, there's some accuracy concerns with some of the input data sets and some of the modeling. You know, applying a USDA county level soil survey at the vineyard scale is probably a little bit more than the folks who put the soil surveys together had in mind, but it gets us in the ballpark, and it's the best data we have. Typically, it's nice to have some local soils data from the vineyard, particularly for gravel content, that can help us then adjust the soils data by block for individual vineyards. Grower irrigation logs, some growers keep great records, others don't, just like the rest of us. And so we're always working with growers to improve the accuracy of their logs. And so we install flow meters out in the field to do that. And then finally, rooting depth it's always a little bit of a mystery parameter. You can't just drill a hole and look down and see where your roots go, because some roots go down 3, 4, 5 meters. And if you give the vine that much access to soil moisture, then the model will say, well, the vine never needs irrigation. So in terms of that estimated rooting depth, we like to think of that as about 85 to 90% of the root zone defines that depth. And so sometimes that's limited by rootstock. So if we know the rootstock that the grower used, we can get an estimate of how deep the rooting depth would be based on the vigor of the rootstock. We can also, if we have some local soils information, that might indicate hard pans. That helps us to set the rooting depth as well. A little bit more on the accuracy of the irrigation logs, because this is something we really try to focus on with new growers. And it's something that's important, but it's also something that's difficult to scale because we have to go out in the field and install equipment to measure it. But this is a grower we worked with out in Fresno, and you can see that grower's logs were what was going into the logs on a weekly basis was much higher than what we were actually measuring the flow meters. So when we take the grower data and enter that into the model, then we're not showing very much water stress. When we actually took the real measurements, the grower was actually doing a lot better. in this point of the season, we actually spoke with the grower about this, and the grower did a much better job afterwards of making sure that what was going into the logs was actually what was going onto the blocks. Last year, we also did a trial, so I'll talk just real briefly about this. Then we'll talk about real briefly how to set things up for an individual vineyard, and then we'll wrap things up and take some questions. So we set up the trial in 2 vineyard blocks down in Monterey County near King City. KC 1141 is a Chardonnay block, and Pine Creek 832 is a Merlot block. And what we wanted to know, basically, can we successfully implement an irrigation trial? They're not easy to do. And if so, can these VCM reports somehow reduce field visits, either through reducing the number of leaf water potential measurements, and or can they save water? And then, given these forecasts that we apply to the trial block, do we see any differences in yield or quality? We certainly would not want to suppress yield or quality within the trial itself. And so, again, we did 2 blocks. Each trial area was 40 rows by 80 vines, so a fairly large area, and that was because we wanted to be able to get satellite imagery, NDVI imagery directly from the trial block, and you can see some of the different spacings, and gravel type was markedly different between the 2 blocks, as well as the peak canopy. The KC block had fairly high salt contents in the irrigation water, and so salinity is starting to become an issue in some of these blocks down there because we haven't had a good soaking rainfall to clear the soil profile in a few years, and so that causes salts to build up in the soil. And again, we just ran the VCM forecasts like we would, the only exception being that we brought in measured irrigation data using flow meters rather than relying on the grower irrigation logs. Growers then received the forecast twice weekly on Tuesdays and Fridays, and this trial ran from mid-April through September. Just in terms of setting up the trial, then we had to add, I say we, the grower actually did most of the work on this, added 2 additional lines through the block. One was a bypass line to get so that the portion of the block on the other side of the trial or downstream from the trial could get the grower prescribed irrigation. And then we had to add a second line so that we could put on more water or less water than the grower was putting on. So and then with each of these, with the primary and secondary drip lines, they both had valves on those, and we could turn those on and off. And so that was 40 rows times 2 valves per row that had to be adjusted for each irrigation. And so appreciate the folks who were out there climbing under the wire and walking up and down the rows to turn those valves on and off. In general, I think in terms of the growers getting the right amount of water on the trial block, they did a great job. Measured irrigation matched what was forecast for those blocks. In terms of water savings, what we did is we compared the trial block versus the control. And so for the Chardonnay block, we actually estimated that the grower should have been putting on about 8% more water given the targets that they've defined over the growing season. For the Merlot block, we saved about 27% water given the grower irrigation goals, and so we felt like that was a pretty good success. In terms of the yields, the clusters per vine, we took 9 vines, we counted the total, pulled off all the clusters, counted them, and then weighed the clusters. We didn't see any significant difference in terms of the clusters per vine or the yield per vine with a sample of 9 in each trial and control. And in terms of the wine quality, bricks being a measurement of the sugar content, the pH, and the titratable acids, we didn't see any significant difference either in those, but we only had 3 samples there for each trial and control block. One note, the grower did note improved juice color in the Merlot block, so we thought that was great to see that. So finally, if you're interested in running VCM for a vineyard, what we need is we need to build the shapefile for the vineyard. And if you don't have that, we can certainly help the grower to build that. If we have a KML file, we can convert that to a shapefile. We need the grower irrigation logs, and typically what we like to do is run the VCM model on the vineyard for the prior year, so for 2014, and let's look at how well VCM does over the 2014 season to see how well it's working. We need some block-specific data, just block names, some vine row spacing, varieties, rootstocks, and some information about the emitters so we can convert from hours to gallons per vine. And then some additional data that we like to have would be some local soils data, maybe some measured irrigation measurements to verify the logs. But again, if the grower doesn't have that, that's all right. We can collect some of that ourselves. And then it's also nice to have some measurement of the water balance over the season, either through leaf water potential or soil moisture, so that we can compare what the VCM model is saying for those two parameters versus what we're actually measuring. So just in summary then, water balance plus these freely available geospatial data sets, I think, are a powerful tool that we can bring a lot of good information to the agricultural industry. We can make weekly forecast estimates if the grower can define targets. VCM compares the targets to the estimated stress, and then estimates irrigation if the estimated stress is greater than the target. Another thing we can do with some of the summary reports for the prior years, we can evaluate the grower irrigation schedules. So if the grower tells us the targets they want to hit by the certain dates, we can see how well they did at achieving those targets. And then we can also look at VCM estimates compared to measurements and evaluate how well the VCM model did in estimating soil moisture, vine water stress over the course of the season. And finally, it sort of backed into some of this, but you can also use a water balance model for troubleshooting. I didn't really talk about this, but typically if you feel like you have all your inputs correct, and you're still getting bizarre numbers in your water balance, this can, sometimes it can point out bad inputs. It can point out blocks that might have pests and diseases. So for example, one block we worked on with a grower last year, the grower put quite a bit of water on the block, but it wasn't showing up as increased canopy growth in the NDVI. And so it was sort of curious, well, what's going on? Well, we went out and dug some soil pits, and we found that the block had quite a substantial nematode problem, and so the rooting depth, the roots had been chewed back, and the roots might have only gone down about 1 foot into the soil. And so it was a challenge block, and by looking at these sorts of things, we can get some early indications of maybe there's something going on in the block that we're not seeing. So that's it. That's all I wanted to talk about today. And there's some of my information there. If you want more information, feel free to send me an email or give me a call, or you can also visit our website. The address is up there.